Hi everyone, we are from team number 10 from SER 502. I'm Anusha Samala.
Hi, I'm Kritika Bhatt.
Hi, my name is Nishchal Kumar.
Hi, my name is Paulo Jain.
Today, we are here to present our programming language called Nirvana. Nirvana is a simple imperative programming language. It closely aligns with C. It provides all the fundamentals that are commonly used in programming. Hence, it is very simple for a beginner to get introduced to the world of programming with Nirvana. The key components of today's presentation include the design flow, the grammar, the parse tree, the compiler, and the runtime. In the design flow, we have generated our nirvana.g4 file for the EBNF grammar. This grammar file is then run on Antler to do the lexical and syntax analysis. The Antler tool generates the parse tree using which we have generated our intermediate code. The intermediate code used in Nirvana is assembly language code. This assembly language code is then evaluated in the runtime to get the appropriate output onto the console. The runtime is also designed in Java. Following are the features that are included in Nirvana. It has two data types, int and boolean. It also supports the basic arithmetic, comparison, and logical operators to do such operations. Operator precedence has also been included to handle correct outputs. The conditional constructs include the if-else and the nested if-else. For the looping constructs, we have the for and while loop. Overall, Nirvana has a very simple syntax. Let's start with the grammar details. The first data types are the integer and the boolean data types. Integer data type has been declared as a grammar rule as using the regular expressions. Boolean grammar rule contains two values, true and false. These are the examples of how we can write the integer and boolean data types in Nirvana. In the declaration part, we declare the variables to hold the integer and boolean variables. The following grammar rule shows on how the integer and bool data types can be declared. For integer data type, the int keyword is followed by the identifier. If we want to assign any expression or value to the identifier in the declaration itself, then the int keyword is followed by the identifier and the assignment operator is followed by the expression. It's the same for the bool data type, where the bool keyword is followed by the identifier. In case of any comparison that we want to assign, it can be assigned using bool followed by the identifier, the assignment operator, and the comparison or the boolean rule nodes. These are the examples of how we can declare a variable in Nirvana. Int x denotes just the declaration without any values or assignments. Int a equal to 5 plus 9 denotes the expression and the assignment. Hence, in this declaration, a will have a value of 14.
Hi, this is Kritika. I will be going through a couple more grammar rules for our language. One of the basic statements included in any language after declaration is the assignment statement. We simply write the identifier with an equal to sign, and then on the right side we write what we want to assign to the identifier. This can take the form of either an expression, a comparison, or simply a Boolean rule which is a value true or false. The syntax for the statements is pretty straightforward. The expression or comparison is evaluated first, and then that value is assigned to the identifier. In this example, Boolean C will be true as we have assigned the value of A to A in the first statement. Next, we cover the arithmetic operations, another requirement for any programming language. The grammar syntax is recursive and hence can handle large arithmetic operations. We have included support for add, subtract, multiply, divide, and modulo. In addition, Nirvana can also handle inverse of values. Our language also follows the normal precedence rules, so add and subtract will have a lower precedence. We can see the valid syntax for our arithmetic operations is pretty similar to maths in general. In the example given here, a will store the value of 30 as 16 multiplied by 2 and 8 divided by 4 will be calculated first as they have higher precedence. The next few slides cover the comparison and logical operators included in Nirvana. The language can compare two expressions. These are comparison operations like, say, if x is equal to y, if x is greater than 10, etc. The language has a very easy to follow syntax as we can see in the examples here. In the same vein, logical operators like and, or, and not are combined with the basic comparison operations. We can see in the grammar rule that comparison statements are evaluated and then their results are compared through and or operators. We can also get the inverse of the comparison using the not operator. In this example, the condition will evaluate to true only if either of the or statements on the left side of and is true and the statement on the right side of and is also true. These operators are usually used with conditional constructs. In the case of if else, the conditions are evaluated and if they are true, then the corresponding statements are executed. We can see the grammar rule here for if, else if, and else statement. The syntax is simple. The only thing to remember is that at the end of our if else block, we include a semicolon to show that the construct has ended. In the example provided, if x is greater than y, the statements in the first block are executed. If the first two conditions both evaluate to false, then x will be printed. Now Paulo will take over the rest of the presentation.
Now let's take a look at the grammar for the while loop. The while loop starts with the word while, and then we have a condition, and then we have a block. Condition for this case, we have x less than 5, and for the block, we have x equal x plus 1. As long as the x is less than 5, we can continue setting x equal x plus 1. Also, we have the grammar for for loop. A for loop is quite simple and similar as the while loop, but instead we have assignment, we have condition, and we also have another assignment. So, for example, right here we start with an assignment x equals 0. We have a condition, and then we have another assignment, and there's this one. We have the block here. Also, we define a grammar for the print. Print, we start with the word print, and then it can be followed by expression, condition, or text. This example right here, we have a print plus 6 plus 4, which is an example of printing expression. And in this case, it's going to print 10 because 6 plus 4 equals 10. And also, we have an example for print a text. In this case, just the text is hello world. Also, we have a grammar for comment. For a single line comment, it's just followed by two forward slashes. It's going to indicate we are commenting just a single line. And then when we have a forward slash plus an asterisk, that means we are commenting a block of comment. This slide right here, we have a summary of all the grammars we have defined for our language. Here we have an example of a parse tree. On the left, we have a code which is more similar with what we have in C++, and here we have the parse tree. This parse tree is representation of this code on the left. As you can see, the Boolean expression x equals true, we have on this side right here, and the if statement is all this side right here. As we see, it's gonna print x is here, where print x is handled right here, and print no is handled right here. Also, we had to take care of the intermediate code generation, which is quite simple because we start with a file, nirv file, and then the handler gets this file and produces the lecture and the parse tree, and then this parse tree comes to a visitor part implementation, and finally we build the intermediate code, which is gonna come as a file in the format NIRC. Here we have a clear example how we transform the simple code as we can understand to intermediate code. For example, here we have int a equals to 5, int b equals 6, and print a plus b. So that's how the intermediate code is going to be generated. So we have 5 is moved to accumulator, and then the accumulator is moved to a, and then we have 6 to follow the same process, and then these elements have to be read, and then they have to be added, and then as here we add, and then we print the accumulator, which store the value of a plus b.
Hi, my name is Nishal Kumar, and I'm here to talk about the runtime generation of our programming language Nirvana. The runtime environment basically takes up the .nirc intermediate code file and runs it on a stack with the program counter to track the execution of the program, and then will print the outputs on the console. The runtime environment for Nirvana has been developed using Java. The runtime reads the intermediate code instructions line by line as seen in this slide. So initially we have an integer declaration and a print of an expression a plus b. So as you can see in the intermediate code, we will move the value 5 to the accumulator and the accumulator value to the variable a. And then we will move the value 6 to accumulator and move the accumulator value to the variable b. So next step is to read the two variables and then add it, and then perform the necessary operation on those two. So basically in this command we have print a plus b, so it will print the value in accumulator, displaying the output in the console. So this environment is handled using Java. The runtime reads the intermediate code instruction line by line and executes it using a program counter. So the entire environment is handled using a stack of hash maps, which is used to track the environment at any time. So each hash map stores the variable and its value, and which will be retrieved as per requirement. The condition constructs are also handled in the same way, but it will be evaluated based on the condition in the expression. So now let us see the evaluation and the execution environment for Nirvana. To execute the program from command prompt, we need to use the command java-jar nirvana.jar with an option f and then the file path of the uh, program. So once we enter this program command, the compiler will directly compile the execution of program and then display the path of the intermediate code which is generated. If the program has any print statements, those statements will be displayed in the console. Here we can see it will say welcome to Nirvana.compiler, and it will display the output of the program, and it will also show the files of path of the file where the command is where the intermediate code is generated. So next we also have, let us see how we can generate program the Nirvana. Now let's see how to program Nirvana in command prompt. To do this we use a similar command, but we will change the option to C. When we use this option, we will initialize our interpreter, uh, and here we can see the number of options that we have. We can use the commands compile or run to execute the command which you entered. We can enter help to see the command Nirvana help, and we can either quit or exit to see uh, to exit the compiler. So first let us see the help window. So when I type help, I will see the way we can code using Nirvana. So it will show the data types and the comments and for loops and all of the structures which we have in a command program. So I can, for a simple programming language, let us see an operator precedence operation using a print command. So here we have two things going on. First is the evaluation of the expression with the precedence, and then the printing of the command expression onto the console line. So first I will say print 5 plus 6 into 7 minus 8. So this is an expression which will be ended with a semicolon, and then I say $, and this will print my evaluated expression, and then it will show you my compiled file path. Thank you.